How? Okay. So just because, we did not get your recording on Bono, just humor me for 1 second. We gotta just capture this, okay? And then capture the music.
There is no music. No music.
Why is
We
there
do not
not
hear music.
music? Wait,
We have never heard music.
wait, you never heard music?
Please do not torture people with music.
Okay, okay. Wait, you heard the music now, right? Okay. Okay,
No.
we've got like Bono video, we got this on video. Okay, and now I can stop sharing and now you can take it away. I'm sorry,
All
I'm
right.
just like really, really tired this morning.
All right. No
So,
problem. But Vicky is tired for a good reason. Vicky's been working and Vicky's been doing all the assignments. So,
no, it's
Vicky
not because I was
actually,
doing the assignments. I actually have to give like a talk in 2 hours and I'm not done. So,
but you've done the assignments, right?
uh, I didn't finish milestone 4 because I needed to start on my presentation last
Okay.
night and I'm still not
But you
done.
did everything else, so still.
Yes, I did do everything
Anyway,
else.
yeah, back to today's topic. We are talking about nested structures, well, at least in the context that, they
Oh.
are presented in its course. And we had a bunch of assignments. We had, I think, 4 assignments. Let me share my screen just so that we're all on the same page. We had a couple of assignments in nested dictionaries. We had not really, I mean, grade boost and animal counts, they weren't really about nested structures. They were more about dictionaries in general. So I would probably talk about these two, like list to dict and finding grandchildren, before we go into the what's it called, the bar bias bar blah blah. I constantly forget the name, but you get the idea. This one, the bias bars, yes, the bias bars assignment. Unless someone had problems with these two, grade boost and animal counts, in which case please do shout out and say like, Alex, can you go through this one, or can you go through this one, and then I will. But let's quickly let's first talk very quickly about nested structures in general. The idea is very simple. When you take data structures that we have in Python, be it lists, dictionaries, tuples, what have you, when we talk about the values that can be elements of those structures, they can be any data type. So what this means is that we can actually have data structures that have other data structures as their elements. And the depth of those data structures can actually vary. So for instance, you could have, remember, like a very separate entity, we discussed 2D lists. Basically, a 2D list is a nested data structure. It's a number of lists inside another list. But you can actually mix and match, and how you mix and match depends on the goals of your program. So depending on what you're trying to do, you would get different nested structures. So you could have a dictionary of lists, you could have a list of dictionaries, you could have a tuple of tuples, you could have, deeper embedded structures, like you have a dictionary of dictionaries, which are themselves dictionary of lists. So you could have 2D, you could have 3D, you could have 4D, you can have any number of dimensions in your nested structures, depending on what the reasons are for selecting that specific nested structure. So the first one that we have here, we have a list that it says might looks like something like this. Of course, it could be different, but the idea is that you have phone numbers of your friends. And at the moment, they're stored in a very inefficient way where you have like a name, then you have a phone number, then you have another name, and you have maybe two phone numbers, then another name and another phone number, and you do not know in advance how many phone numbers you have for each person that's in your list. So basically, the only thing that you know is that you always start with a name, then you have one or more telephone numbers, then you have another name, one or more telephone numbers, etc., etc. And the way you differentiate between names and phone numbers is that phone numbers, well, logically are all digits, although we could make this a bit more difficult by adding an option when you have a plus at the beginning of the phone number. For instance, if you have an international phone number, you usually have a plus followed by the country code, followed by the area code, and followed by the number. This is something that we could play around with. Names, on the other hand, are usually letters or other symbols, although it's not very correct to assume that your name will not have any digits in it, because, you know, maybe you're storing someone's name with numbers. Maybe you're storing someone's names with you know, commas, exclamation marks, spaces, whatever. So I would prefer to take this into account when we go through this problem. What we need to get at the end of this problem is a dictionary which has the names as keys and the telephone numbers as a list for that key. So here, if we take a look, for instance, at the second name, Anashri, we see that the value is actually a list which has two phone numbers in it. The reason why is because after Anashri here, we have two digital phone numbers. The other names have only one number, but it's still a list. This is important. It's still a list which only contains one element. So the question is, how do we do this? Let's go into PyCharm, and let me just copy the example that they have here and maybe make some changes to it. So let's say that, let me just quickly check with you. Do you see my screen? Do you see PyCharm right now? So that I'm sure that I'm showing you what I need to be showing.
I don't see it.
You don't see it. Okay, let me try this once again. No, not this one. Let me share the screen itself. How about now?
Yep.
Okay, lovely. So we have a list which has names and numbers following one another. So let's call it, I don't know, old list. And I will add some more values in here to make this more interesting. So for instance, I will add, for instance, myself, and note that I will add it as a name and a surname. So there will be a space in here. And I will add some phone number, which will start with a +7, which is the country code for Russia. Then I will have some area code, and then I will do just like this. So here the difference will be that I have a plus at the beginning. So this is not exactly a numerical representation. It has a plus. And maybe I will add another number, which is my, I don't know, old home number, which is still embedded in my mind. And we'll talk about working with that. Let me maybe make it a bit simpler to read like this, so that way I can actually see. And in the chat, can I zoom in a little? Yeah, Leo, let me try and zoom it a little, maybe to 32. Is this good? How does this look? So what we need is, let's say, a new dict. Let's create an empty dictionary. dictionary where we will store our new address book, contact book, whatever you want to call it. And the way we're going to do it, there are different ways. As with most programming assignments or programming problems, there are various ways of doing this. But I think it would probably be easy to iterate over the list using a for loop. And depending on what the current value is, we will wrap either take it as a name or as a number and work with it. So let's iterate over indices. So I will go for I in range len old list. And then the question becomes, how do we understand? Do we have a name? Do we have a number? We need to use some string methods in order to get this right. So I would propose to do the following. We will check whether one of the strings is actually a number. And like I said, a number is something which has digits only, or it has a plus at the beginning and the rest is digits. So these are the only two options which qualify to be a number. And if it's not a number, then we know that it's a name. So the condition that we'll start with is going to be if old list I, so the current index is digit. So if you remember, is digit checks whether all of the characters in a string are actually digits from 0 to 9. Or the second, some have a hyphen in the middle. That's true. Let's add maybe hyphens. Let's add some hyphens in here to make this. And well, I mean, if we're hyphens, we can actually also talk about parentheses, because parentheses are also sometimes used. So in this specific case, I mean, you could get very weird. You could get like this, and this would still be considered then to be a legal telephone number. But let's leave this. Let's leave this, at the discretion of the programmer. Could you check last element in string? Sure, you could of course check the last element in the string, but the problem is, let me make this explicit. For instance, if I have a person whose name is Mel2, I have a 2 at the end, checking the last element would not help because then we would think that this is a number, but this is actually a name. So then if we do this, if we want to include hyphens and we want to include parentheses, I would propose first doing the following. Let's do something like a clean string, which would be the following. We would take the item, the element, which is at index I, and we would perform the following actions on it. We would remove, we would have to replace all the hyphens with empty strings. We would replace all the opening parentheses with empty strings. We would replace all the closing parentheses with empty strings, but I will not touch the plus, because the plus can only be at the beginning of the string. So I do not want to accept any telephone number which has a plus somewhere in the middle. So using this chain of methods, I will remove all the hyphens, all the opening and closing parentheses, and after this, I can check. So if the clean string is digit, so if only digits remain, or at the 0th index, we actually have a plus, and let's put this in parentheses to make certain that this is the second, condition. and the remainder of the clean string, so a slice starting with the first index until the very end, is digit. So all the remaining characters in that string are digits. In this case, we know that this is a telephone number. So we're going to do something here, and we'll do this later because first we need to figure out what to do with the name, because otherwise we will think that this is a name. Actually, we wanted to do this as a function. So let's define this function. What was it called? It was called list to dict. Does it take? What does it take in? It takes in a friends list. Okay. I will call this old list. There we go. And we will then call this function with the old list. We'll say print whatever this function returns after we pass the old list into it, something like this. And at the end of this function, we'll obviously return the new dict. I think this should work. So in case it's a name, what do we need to do in case it's a name? We need to create inside our new dictionary using this name as the key. So we'll have clean string. And since we don't have any numbers yet, this will be an empty list. So initially we create an empty list for this specific person. So first we will create an empty list in the new dictionary under the key Noah. Then we'll do the same with Anashri. Then we'll do the same with Mel2, and we'll do the same with Alex Belikov. And that's that. But the thing that we will need to remember is which name we're working with once this is done, because after this we'll have numbers, and we will have to instead of clean list, because clean string will be replaced in each iteration, but we have to remember the name. So what I'm going to do name equals clean string. I will have a separate variable which will remember the last name that we found in the old list. So if we come across a number, the thing that I'm going to do is new dict under this name, and we should assume, or as in programming say assert, I will assert that this name will already be in the new dictionary, well, given the way that the data is presented. So I always take into account that the first one is always the name and then the number. So for instance, if someone writes something like this will break our program because a telephone number cannot be the first one. But if the old list is correct in how it's filled out, then I assert that at this point in the program, there will be already a key name. And what I need to do is to actually append to that key, to the list which is stored under that key, be it an empty list or a list with one or more numbers already. I will append the new clean string. But the question here is, how do I want to store those telephone numbers? Because I believe in the actually in the example here, they're also stored as strings, so we do not need to turn them into integers. So I'm not going to turn them into integers. The reason why name is underlined yellow here, because Python is saying, are you sure, Alex, that name is going to be here? And to make this go away, I would at the start do something like name equals none to make sure that there is at least some value stored in name, although I hope that we will not get none as a key, because some other string will replace that none before we start adding something. And I think that this should do it, but we have to run and check whether we get any errors. So let's see. This is the result that we get. We have Noah with one phone number. We have an Ashri with 2 phone numbers. We have Mel 2. So this 2 did not fool our script. Our script works. We have the number for Mel. And notice that both in an Ashri's case and in Mel's case, we lost the hyphen, but usually the hyphen is not an important, unlike the plus sign, a hyphen is not an important part of a phone number. If we had to include that one, we probably would have used here, instead of clean string, we would have used old list I think this would have worked as well. Let me check. Yeah, there we go. We could do this. We could store it the way it was initially stored. So we have the hyphen here, we have the hyphen here, and we have these phone numbers with all the pluses and the parentheses and what have you. So it seems that it's working. Are there any questions, any comments, any ideas on this specific script before we go to the next one?
It's easier if you just do alpha on the first character of the string.
Sorry, one more time. If we do what with the first character of the string?
Instead of your if looking for is digit, the whole entire thing, if you just do is alpha on the first character of the string.
Okay, and
if that's true, then it's a name. Otherwise, it's a number, and you know that they're always in that order, name, number, even though there can be more than one number. Then.
But what if I do a name like this, or what if I do a name like this?
I mean, you're never going to have a name like that, but sure, yeah.
If why not? I mean, I could write something like, I don't know, I'm just fantasizing, second friend. I don't remember the guy's name, like second girl from the bar, if you know what I mean. And then you're sort of starting with a number. So the reason I'm doing this is that I want to be more explicit about what a number is. A number is just digits, maybe starting with a plus, but everything else could be a name.
I mean, yeah, sure. But, you know, given what you've done, you can have a lot of problems, even names with dash in between, like Marie Antoinette or Anne-Marie. So, you know.
Yeah, but I wouldn't have a problem with Anne-Marie because, I mean, if we do, let's try doing something like.
No, it will just clean the name.
Let's say it's 1, 2, 3, 4, 5, 6, 7. We could here also, instead of clean string, we could also do the old list I. It would get rid of the dash when it's checking it, but then it would append the correct one, I believe, unless something breaks right now. Anne-Marie, why are you not working, Anne-Marie? Because okay, the name should be as well done, old string, yeah. Old list, like this. And then there you go. I have Anne-Marie as well with my phone number and the dash whatever. So I do agree with you that, you know, we could probably run into some weird things that I'm not thinking of right now. And if we go, you know, strictly by how the assignment is written, we don't even need to worry about this. So this is something that I just came up with to make it a bit more difficult. I just thought that it would be a good exercise to look at some of the things that you would have to think about if we're writing a real program and not just a very simplistic assignment. Let me check. You might be storing conquest numbers based on your rating of them in the SAC. For instance, actually, I think that use case is real. Second girl from the bar. I wouldn't be surprised. Never applied to me. I would never do anything like this, but I think it's a real use case. So yeah. Marie Antoinette. I don't know. I heard Anne-Marie, but you never know. You never know. Maybe Min does have Marie Antoinette in his Yeah, okay, so I misheard completely, but yeah, sorry. Anyway, let's take a look at the bloody revolution. Why not? I mean, why not? If you do a revolution, it has to be bloody. Otherwise, it's boring. So let's take a look at the second one. The second one is called finding grandchildren. So let me copy this from the assignment, and let me create a new Scratch file named Scratch2. So what we have here is we have a list, a dictionary, which is a nested structure where we have names as names of parents as the keys and names of their children as the values, a list names. So if there are more than one child, you have a list of, for instance, 2 elements, 3 elements, etc. If it's only one child, you still have a list with only one element. Oh, okay, you said both. You said both. So I'm not imagining things, thank God. So what we want to write here is to create a function which will give us a dictionary, which we would probably call something like grandparents to grandchildren. So the idea is we need to figure out who are the grandchildren of the people we have here as keys. So basically, if we have Haled here and one of his children is Jasmine, and we look that Jasmine has supposedly a son named Frank, then Frank is the grandson of Haled, and we need to show this in the dictionary that we create. So let's write a header which will be get children or something to that effect, doesn't matter. What we have here is parents to children as the parameter. And after we are done, we will print once again the result, get grandchildren, parents to children. So we will print out the resulting dictionary. We'll call the dictionary grandparents to grandchildren to sort of be similar to this one. Initially, it's going to be an empty one. At the end of the function, we will return it. Yeah, if we launch this right now, just to check that it's working, we will get an, there we go, we got an empty dictionary, so that works. Let me quickly check the chat. Let them eat cake, Abhinav, correct. Sophie von Anhalt-Zerbst. Why not? I mean, why not? So, how do we do this? The idea is the following. We are going to go through the parents one by one. So we're going to iterate over these names. And when we iterate over these names, we are going to get access to the names of their children. And the thing that we're going to do another loop. So there's going to be an inner loop, which is going to go through the children of those children if that person has any children. So for instance, in our case, here we have, I'm not sure how to pronounce this correctly, either Chibundu or Kibundu. So this person does not have any kids. So obviously, Haled does not have any grandkids from their offspring, direct offspring. So the first thing we do is we will go for parent, or we can actually say for grandparent, in parents to children. And this way we get access to this list. So the way we do it is we have parents to children, grandparent. We have access to the list. And here we're going to do for child in the list. So we're iterating over the list, over the children in the list. And then what we're going to do, we're going to check if that child is present in the initial list. So if it's both a child and a parent. And if the child is present, then what we're going to do, we're going to take the children of that child. So in order to do this, we would need to go parents to children, access it with child. And this way we will get the list, or for instance, in case of Jasmine here, we know that Jasmine is present in this list. So by parents to children child, which is Jasmine, we get access to this list, which has the name Frank. And what we need to do is actually add that name to some key in our new dictionary. So we have, first and foremost, we need to create that key. To do this, let me think of the correct place to do this. So we have for grandparent in parents to children. Okay, let's call grandchildren. We'll create a list here. This will be the list of grandchildren for this specific grandparent. And if we have it here, we can concatenate two lists. There are two ways to do it. For me, the simpler one is this. We can use the plus operator to add this list. So in our case, for instance, for Jasmine, it would be Frank. We will add Frank to this list. So we now know that Frank is a grandchild of Caleb. And after this,
can you use append there?
Sorry?
Can you use append to add to the list?
You cannot use append. You can use extend, because we have two lists. You cannot, well, I mean, you could append the list to another list, but then you would have the list inside that list, which is not what we're aiming for. So you
can unpack it.
Sorry?
You can unpack it with the star.
You could unpack it with an asterisk, that's true, but then the question becomes why. So it's obviously easier.
No, it's if she wants to append.
Right. But I mean, then the question becomes, why would we append and then use the star? It's easier to either concatenate the lists or extend the list, but you are correct. If you want to, you could use append. It would just give you like extra steps that we don't need. The keys aren't grandparents yet, just parents. Well, I mean, the keys, I mean, for me, they are already grandparents in the sense that we're going over potential grandparents. So it works for me, but obviously you can use parents here as well. It's a matter of preference. I'm sorry, give me a second. Someone is bombarding me in WhatsApp, and I have no idea who that is. So let me just turn it off, sorry. So after we're done with the inner loop, so we went through all the children for a certain potential grandparent and checked their grandchildren and compiled this list, we need to check whether this list actually exists. I mean, if it's still empty, then that means that this person does not have a single grandkid. So we're going to write if grandchildren, which means if there is at least one grandkid in there. We could do this like this, not equal to an empty list, but we could just write if grandchildren, because an empty list is always a false value, and the list which has elements is true value. So if there are grandchildren, what we're going to do is add to our grandparents to grandchildren. We will add our grandchildren list, but then the question becomes, what is the name here? And the name here is grandparent. Let me quickly check the list. Daniel becomes great GP at end. Does he? Oh, he has, yeah, 1, 2, and 3. Exactly, yes. He is the guy with the most, the ghost with the most, as they say in Ghostbusters. No, that was Beetlejuice. Beetlejuice is the ghost with the most. I'm sorry, Beetlejuice. Oh, I said that 2 times. I'm not going to say it the 3rd time. Let's check whether this actually works or I've made any mistakes. We have Caleb, we have Frank, we have Daniel with Kibundu or Chibundu, Jasmine, and Grace. And notice this is important. We do not have Jasmine because Jasmine is obviously not a grandparent yet, and we do not have Eve because Eve is also not a grandparent. The reason for this is that we included this condition, because if we were to remove this condition, we would have something worse. We would have 2 names with empty lists, which is obviously not something that we would want to have in terms of, general usage of this function. So this is the way this would work. Are there any questions, comments, ideas?
Yeah, Alex, so I'm sorry. Okay, like 2 questions. So I had a question about line 16, if grandchildren.
Yeah.
So what is the syntax there? If you just say if grandchildren, does that just mean like the list of grandchildren is not empty?
Yes, the reason for this is, if you remember, we discussed that any value of any data type is either true or false when it's inserted into a condition. So any data type would become either true or false. And for lists, empty list equals false. Any other list
So
equals
clarification, empty list does not equal none.
No. None is an entirely different data.
Yeah, okay. And so
I-
instead of saying if grandchildren there, can you actually change it into a Boolean and say if grandchildren equals, I don't know, true or something? Would that be
you
equivalent?
could write this,
Yeah,
but
okay.
redundant.
Okay.
Because
okay.
then you're checking whether true equals true, which is obviously true. So,
well, because I feel like if I wrote grandchildren equals true, okay, it's a little bit easier for me to understand versus just if grandchildren. Because like if grandchildren, I'm like, what does that mean? I mean, I kind of concluded it probably means like the list is not empty, but I wasn't really sure.
it's actually in terms of human readability. I think it's quite good, because if it says if there are grandchildren, because if you wanted to check if there are no grandchildren, you would write if not grandchildren. Like I said, if it's easier for your eyes, you could do this. Also, you could do this, sort of saying if grandchildren are not an empty list. But you see, even PyCharm underlines it and says, why are you doing this? Stop doing this. Make it simpler. Replace it with another expression. So.
Okay. And then can I just ask you to comment something? I mean, you don't have to like explain it because I think you did explain it. I just didn't quite follow. So from lines 11 till 15, okay. Can you just write a comment next to your code with an example, okay, as to who the grandparent is?
Sure.
And then who the child is, okay? Because I'm just not thinking very straight. So
okay, well, let's go through. So here we're going over the keys of the original list. So for instance, on the list dictionary, so for instance, the first one is going to be Caleb. Here, obviously,
wait, why are you calling? Okay, if you're going over that dictionary, why isn't that parent? Why is that like for grandparent?
Because it's my decision. I can call it whatever I want.
Okay.
I can call it X.
You can call it whatever you want.
Like I said, for me, since these are potential grandparents, I could have written potential.
Okay, got it.
I could have written parents, and someone else asked.
Okay.
No problem. I mean, it's your decision. So in my case, I thought, well,
Okay.
Caled is probably a grandparent because it's easier, to add it later. It looks logical. So if we have this guy, this is self-explanatory. So then we go for child and
Sorry, I did have a question about line 12. Okay. Why does that list have to be within the for loop and not outside of it?
where would you put it? Would you put it here?
Yeah.
Like
If
this?
I were to put it,
Sure. Actually, the easiest way to get your answer is to do this and run the program and see the result. It's a lot easier to explain because now, as you will see, everyone is everyone else's. So it's a total mix of everything. Because you took all the grandchildren and you put them all in one big list without renewing it for each new grandparent that you're checking.
yeah.
Does that make sense?
Yes.
Okay, so that's the reason it's sometimes easier.
I have a question also, following up on what Vicky was asking about in your line 11.
Yeah.
Is it the case that when you have nested dictionaries, I mean, even more complicated than the one we're working with,
Yeah.
that when you write the code the way you did, like in the name of the dictionary, okay,
Mhm.
the first thing that gets iterated is the primary key, right?
Yes.
Okay.
It would be the same as if I did this.
Okay, that's what I wanted to be clear on, because when we're getting into these nested lists, it gets a little complicated. And I thought that was the case, but I wasn't sure.
Sure. It goes over, well, you put it correctly, the primary, the outermost list of keys.
Right.
Sequence of keys. It's not a list, it's a sequence of keys. Yeah.
Right.
All
Like
right.
Vicky, as I'm kind of new to this, it's kind of hard to like take it all in. And so sometimes I will write things also so I know what's going on, even though I don't have to.
Sure. Okay. Mika, I see you're thanking the guys for asking for an explanation. Please do ask me as well. Don't.
I was actually going to, Vicky then.
Okay. Okay. Cool. They beat you to it. Do not be afraid to ask me. I mean, I don't care how many times you ask me. I want you to get it before we move.
No, I'm never afraid of asking, even if people
I
get
know.
annoyed.
One of the reasons I love Vicky, she always asks questions. So yeah, follow her lead.
Absolutely.
I mean, it's like my learning, so you got to be a little selfish. So,
Sure.
well, I mean, my meaning your learning. And so it's okay. We don't ever have to see Alex after this again. So like
Wow.
squeeze every ounce before we are.
Just drain those juices from me, right?
Mhm.
Okay, so I think we're clear with this one and with
Yes.
this one.
Okay.
So
So
let's
the
go.
child and parents to grandparents. Okay. And so this we're talking about like Chibudu, Jasmine, blah, 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 right?
Yes, we're going over the values for the Kaylet key.
Okay.
And what we're checking here, if this child has children of their own, so if Khaled, sorry, not Khaled, in our case, for instance, Kibundu, the first one, if Kibundu does have kids of their own, and obviously they don't, so in this case, we skip this.
Okay.
But
this is where I got confused because I didn't really know how to write the child, okay, how to write to check if the child has children of their own. I was trying to use, yeah, I mean, I just didn't know how to write this. Is it really as simple as just iterating over every child and then checking it in the dictionary?
yeah, it's as simple as that. You just check using the in operator whether something is present or absent in the dictionary.
So wait, let's see. For child, going over the values. So the child in line 13 and 14 is the same child, right? Except in one case, we're checking like child as the value, but in line 14, we're using the child as a key.
Yes. In this one, child
Child is the
as
value.
you correctly put it, we're going over the values. And then we check whether that value from here is actually the key in the same dictionary.
Okay. Okay, got it. Thank you.
No problem. And then basically, if this child has children of their own, so for instance, in case of Jasmine, we have this list with Frank, we add this list with Frank to the grandchildren list, to this one. So, and after this, it becomes, instead of an empty list, it becomes a list with one value, which is Frank. And here, once again, it's important not to append, because if you were to append, the result would look like this. You would actually have a list inside another list, which is not what we're trying to do. So this is why we need to either add, or another thing, I think the way you did it, I remember you showed me the code, is you actually extend instead of append, like this.
No, actually, I used append, and then it worked, which is why I was like.
But I mean, the code you showed me, you used extend. That's
Oh,
why.
yeah. Sorry. Okay, I got confused. I was
They
looking.
sound similar.
Yeah.
So as you can see with extend, the result is the same, but if I do append, just to, it's better to see.
Yes.
You'll get this weird thing where you have Frank, and you have, well, not exactly what you're looking for.
So, Alex, I'm getting a little bit confused on line 13 for child in. I know that we're going through that and going through every grandparents list. Sorry, every parents list. And then if child in parents to children, but every list has a child, right?
So, for instance, let's go through the logic one step at a time. So we create this empty dictionary. We start going over the names of the potential grandparents. The first one is Caleb. Yep. We create an empty grandchildren list specifically for Caleb. So this is Caleb's grandchildren. It's gonna be Caleb's grandchildren. Mm-hmm. And then we start going over this list here, the items in this list. The first one that we go through is Chibundu or Kibundu. I'm still not sure. Someone help me out here. And then we're checking, is this person actually in the list? And we see that Chibundu is no, so they don't have any kids. So we go to the next child. The next child is Jasmine. To see, does Jasmine have any kids? And we see, yep, there is a key here called Jasmine. So Jasmine has kids. So what we do is take her kids. So we're going to this dictionary with Jasmine as the key, because at the moment child is Jasmine. And we add its contents to our grandchildren list, which is the grandchildren of Caleb. So now grandchildren becomes Frank. We are done with the inner. There is no one else. It's also only Chibundu and Jasmine. And then we check, is there at least a single grandchild? Yes, there is, because there is Frank in there. So what we do is, in our new dictionary, we use Caleb as the key and a list with the name Frank as the value. And we get, let me launch this to give you the correct result, we get this.
So Alex,
Alex,
despite your further explanation, I am also sleep deprived and still having trouble following some of this. So when you explained to me, when I asked about line 11, that got, because the term for grandparent, as you said before, it could be X. It's just,
right.
You're choosing to use a word for the key in parents to children. And you explained that in that line, the assumption was you're going through the first level of the dictionary
Right.
of whatever the nested structure is. But then in line 14, I got really confused because child is not the first level of the dictionary. So how come that works?
Because these two loops they're not connected in any way, in the sense that at the same time, one person can then be both a child and a parent. Because Jasmine is the child of Caleb, but at the same time, she's the parent of Frank. So there is no contradiction here, like in real life. Both can happen. And for the outer loop, I use grandparent for the person who I'm actually checking right now to see whether they have any grandkids. And for the variable child, I am looking at the person who is this potential grandparent's child. So when I say child, I mean like their child. Like once again, I could have written here something to be more explicit, like if not child, but for grandparents' child, something like this. But it makes it too, it's like too much.
Yeah, I'm not really confused by the arbitrariness, Alex, of whatever word you use to represent the key. I'm just more confused about the structure of going through nested dictionaries that could be much more complicated than this one, and trying to search for things within inner dictionaries. And so I got what you did in line 11, but my brain is still struggling to understand line 13. And maybe it's because you have children with the key grandparent in there. And so that's why it works. If I'm explaining myself well, I may not be.
I'm still trying to understand what in which part you're confused.
So I'm confused by in line 13.
Yeah.
What the keys are that you're searching for. How do you get to the list of children?
Okay, so your question is, how do I get to this list using this syntax?
Yeah. Exactly.
Okay. So let's first look at what I'm iterating over. I'm iterating over whatever is stored at this key in the dictionary parents to children. So if I have in the first outer iteration, if I have Caleb as grandparent, this becomes this. If you look at this, this becomes this. Like
okay,
this is what
I'm starting to understand now. So I do understand when you wrote it as that you're looking for the keys in Caleb. Then I get that. So I think I'm sort of getting it now.
Okay. So yeah, that's
just to follow that thought though, Alex. So now when you say if child in parents to child, so with that example, you would be saying, like, for example, if Jasmine is in the parents to child, then we add her to the new list.
exactly.
Right?
So here, once again, I'm checking the keys. This is the same, this would give us the same result. I'm looking if the word child, so for instance, Chibundu or Jasmine, the variable child, the string, is present among these keys. And Chibundu is obviously not present. They're not here. Jasmine is present here. So I do not add anything for Chibundu, but when Jasmine is there, I do add Frank.
Okay. So we add the value of Jasmine's key. Like
yes, we add this value.
Yep.
Because here we're saying who child is Jasmine. It becomes Jasmine. So this becomes this. right? Do you follow me?
Yep.
And then now this is added to this, so it becomes this. And if you add something to an empty list, obviously it becomes that list.
Yeah.
Okay, so maybe, I mean, if we look at the more complex situation with who was our second granddaddy, who's your granddaddy? Daniel is your granddaddy. So we go through second iteration, for instance, let's say it's not Caleb, let's say we're going, for example, over Daniel. Now this is going to be Daniel's grandchildren, and we're going over the values for the Daniel key, and we get Caleb and Eve. This is Caleb, this is Eve. So now we're checking both, we don't need keys here actually, we're checking both Caleb and Eve. And first we have Caleb. Caleb is present in our dictionary, so this condition becomes true. So what we do, we actually take whatever's stored with Caleb here and add it to grandchildren. So basically this list is added here and becomes this. But then in the second iteration of that loop, we get to Eve. Now we're looking at Eve. Do we have Eve? Yes, we do have Eve. She has Grace. So the next thing we're doing here, we're doing this. And when you add two lists together, you get one list. And this is it. And this is why we get this result for Daniel, because here, obviously, grandchildren is not empty. We have some values in there. So we add it to our dictionary under this key, which is Daniel, this list, which has 3 grandchildren.
And how does it know that that's Daniel? Because it's the first index?
We know that it's Daniel because at this moment we are iterating supposedly over Daniel. So before Daniel, we did the same for Caleb. After Daniel, we're going to do the same for Jasmine and then for Eve. But since Jasmine and Eve do not have any grandchildren, we will not add them. So this is simply the order in which the list is iterated, the dictionary is iterated over. Like first this, then this, then this, then this.
Yep. So that's the outer loop and then the inner loop. Got it.
Yeah, exactly.
Thank you so much.
All right, no problem. Did we have child here? I am already confused myself. Yes, I think so. Let me check once again. Yeah, everything seems to be correct. All right, any more questions, clarifications on this one? All right, so
question.
Yeah, Tatiana.
What? Yes, thank you. I don't know. I have losing some part of course. I don't know if it's not actual. Don't answer. If I work with as a teacher, and sometimes I need to have also lists with different parents. Some father telephone, mother telephone, grandmother telephone. How we can change these lists to add different parents to one children, if it is possible?
Okay, so the question is, how would you show that a child has several parents? Is that what you're asking?
Yes, and they contacts, and maybe not only contacts, maybe something else, but one children, and for him several adults to connect, and maybe some additional comments.
There is no one correct answer because you can do it various types, but let me try to take a swing at this. So do I understand correctly that you want the child's name to be the key? So you want to see for every specific child something, right?
Yes.
Okay, so for instance,
or maybe or patient or student, something like that.
Yeah, sure, it doesn't matter. I mean, let's call it students, for instance. So you have a dictionary of students and the keys are going to be named. So for instance, we have Alex, and there is going to be something here. We have Tanya, we have something here, we have, I don't know, Bob, we have something here, etc., etc. But let's say we have a very small class, we have only 3 students. So now the question becomes, what information do you want to have here? And as far as I understand, you want to have the students' parents, or whatever they are, legal guardians, whatever. There could be several of them, and then you want to store their contact information. Is that correct?
Yes, yes. But I
Okay.
mean the different types of relatives. How to different types of relatives: father, mother, grandmother, or
Okay, so it's important. It's important that you know what their relation is. Correct?
Yes, yes. It's very important to know who is it and that name and that contact.
Okay, so my the next question then would be is what's the second most important information? For instance, to give you an example, if the next information that you want is the person's relation to the student, you could do something like this. So this is a nested dictionary. So I will have another dictionary inside this dictionary, and for instance, here I could do something like this. I could do like father. Let me do it like this. And for instance, information that you want for father, you could, for instance, want the father's name and the father's like telephone number. So here you could actually have a third dictionary, which would have name, for instance, like my father is Vladimir. And then you could have the like phone number. And you would have something like whatever. If I were to have another parent, I would add another parent here. I would say, for instance, mother. And once again, I would have a nested dictionary, which would go like name. And I'm sorry for using, you know, single and double quotes. I don't know why I'm doing this, but since I started doing it, whatever. And there would be some telephone number here as well. So in this case, you would have a dictionary of students with their names as keys. And inside, for each of those keys, you would have another dictionary of relatives. And you would have the relationship of that relative as the second key. And for that, each of those keys, you would have, for instance, a third dictionary, embedded dictionary, which would have the name of that person and the phone number of that person. And you could add whatever you want. You could add, for instance, an email. You could add something else. So this is one way of doing it. You could probably do it in a simpler way if you do not want, if you, for instance, know the exact values which you're going to have, like first name, then phone, then email. You could make this easier. For instance, you could do this as a list and just go Vladimir, and you know that under index 0 you have the name, under index 1 you have phone number, under index 2 you have dario@mail.ru, you have the email address. And this is another way that you could do this. But ultimately, it's your decision as the programmer which way it would be easier for you to do this. Does this make sense?
Yes, thank you so much. It's really important, and I think I will use it urgently as soon as possible. Thank you.
Okay, sure, no problem. I like it to say, Adina, you're saying it's comforting to see you mix single, double quotes. I'm a double quote person, honestly. I prefer to use double quotes, but sometimes I get wicked and I start using single quotes and I have no idea why. I think I have a second personality. So, you know, someone is pulling my strings.
If we use together double quotes and single, it will be okay for Python.
Python does not care as long as the opening quote and the closing quote is the same. Otherwise, so if I were to print this, you would actually see that Python turns single quotes, if I'm not mistaken. you see there are all single quotes. So inside Python's mind, it's all single quotes. But I think to answer the question why double quotes, initially when I started learning programming, the course that taught the basics of Python sort of used double quotes, and it stuck with me. So that's the way it happened. I know in some languages, Abhinav, it's not only Go, for instance, basic C uses double quotes for strings and single quotes for single characters. And I'm certain that this convention applies for many different programming languages, but Python does not care, especially since Python does not have a separate value type for single characters, unlike C, for instance. And I wouldn't be surprised if C++, single, for some reason, yes, single is a bit more naughty, I would say. Not evil, but naughty. I don't know, single. Oh my God, single quotes. Stop it. Let's talk about something else.
Alex, I have one quick question.
On which one?
On this last
this one.
phone. Yes.
Shoot.
You see that in Bob as key, the value is ellipsis.
Ellipsis. This is an ellipsis.
Mean?
Okay. I just put an ellipsis here. It means nothing.
Okay.
It's I think it was added at a certain point in time into Python instead of, if you want to say nothing for now, like a placeholder, it's an ellipsis. So don't
okay. Thank you.
No problem. Okay, so shall we move on to the bias whatever thingy, because we have a hard stop today. Vicky, please remind me, because I'm always forgetting at what time. I think we have an hour and 10 minutes, right? I'm not sure whether Vicky is with us now.
I need to reclaim the Zoom by 12:05, and so you have an hour and 15 minutes to be exact.
Okay, good.
I'm sure people would love to have you 24/7 if they could, but the hard stop.
I don't know. I think I tend to wear people out with time, so don't be so.
Isn't he on the forums?
Okay. Sorry. I mean,
like if he's on the forums, because she said 24/7, which
I am on the forums, but I'm certainly not 24/7 there. So, yeah. But I do answer queries in the forum. Let's go then to we don't need the scratches anymore. Let's close these and let's go into the main attraction. So we have the story about analyzing data bias, and I'm not going to go through the backstory. I'm sure you went through it, and if you didn't, do it in your spare time. So the first problem that we have here is sort of like a bit of a warm-up. There is supposed to be a file here called data analysis, and in this data analysis file, there are a couple of functions that we have to write. And the idea is that first we need to read a file which looks like this. So it's not the cleanest file. What we do know about this file is that we have some city, and then we have some comma separated values, but you see the problem here is that they're sloppy. So in some cases you have extra spaces. In some cases, you do not have any spaces at all. In some cases, you have a lot of spaces, and you have to somehow clean this data from the file up in order to store it in this clean-looking dictionary. And in this dictionary, we would have the names of the cities as keys, and this is the number of cases, cumulative number of cases of a disease found in this location over 7 days. So we can be sure that we have 7 values. This is a given. They are all separated by commas from one another, the name of the city and the 7 values. But we need to clean it up. We need to get rid of all the extra white space that can be in there. So how do we do this? Okay, load data. We have the file here. Okay, so we need to write this function. We have the file name given as the parameter. So this is the file name that we need to open. This makes it a bit easier for us. To open a file, let's recall, I will use the with manager, and then I will write with open file name. Since I'm going to be reading, I could write this, but it's not necessary. And since I know that it's all in Latin characters, I'm not going to do the encoding, although I could have written like encoding. I mean, if I'm writing it, let's do it like this. To remind you, if you don't remember, this extra parameter made that the contents of the file are read using Unicode encoding, which makes certain that if it's not Latin letters, they will still be read correctly. For instance, Cyrillic letters or Arabic or Chinese or Korean or what have you, accents, etc., etc. So this is how I open the file. And in this file, let's take a look at the file itself. So you see we have actually 4 strings. This is important because the 4th string is an empty string and we need to keep this in mind. So we have several strings. Some of them might be empty, but most of them have the name of the city. And we need to correctly read this. So we're gonna go through the file line by line. I'm going to write for line in file. So this syntax, if you don't recall, goes through the file line by line. So it takes the entire line as a string. The thing that you have to remember first and foremost is that the /n at the end of the line will be present, and we need to get rid of it by using the strip method. We are supposed to write these subfunctions in different SPI files. Different SPI, I'm sorry, what's a different SPI? You lost me here. What's the difference?
Yeah, so I mean, it took me, okay, so because from reading the instruction, it sounded like milestone 1, right? We're supposed to calculate this percentage, right? And so
we're not doing milestone 1 at the moment. We're doing the sandcastle.
Oh, okay. Never mind. Okay.
So we didn't get to the milestone yet.
Okay. Well, I mean, okay, so I guess what you're saying is like the sandcastles are supposed to help you write the bias bar. Right.
Yes, and then we will actually use
yes. I mean,
we'll use one of the functions from there.
The moment you said that, it clicked. Okay. But I don't know what I was thinking. Never mind, just forget.
Okay, no problem. So we read the line, we strip the /n from the end of the line and get an updated line. So the next thing that we need to do, we need to actually split this line by the comma symbol, because we know that the line has data separated by comma symbols. So we have the name, and then we have 1, 2, 3, 4, 5, 6, 7, disease values, the case values. So for now, I will save this into some variable called data, because what I'm going to do after that is I will take the city name, and city name is data0.strip. So in our case, like the first one, I will take evermore. This will be the data for evermore, but then by using strip, I will get rid of this space so that in the end, the key is actually evermore without any extra spaces. And then the rest, the values, so the city is actually going to be the key, and the cases or the values are going to be, now let me recall, how are we supposed to store it? Are we supposed to store it as the string? Yes, we're supposed to store it as a list, sorry. So the cases are gonna be data starting with the first index, but the problem is that we want to apply strip to each of the values that's going to be added to our cases variable. There are various ways in which we could do this. Let me think which one I prefer to use here. Could we do it like cases in empty list? We go for case in data in the slice. I would want to append to our cases list the value that I'm getting, applying strip to it as well, and then turning it into an integer. Let me first check whether this is doing what I think it's doing, and when we make sure that we get the right result, I will go through it in a bit more detail and answer any questions if you have them. So we have the cases, and here I would need the dictionary. Let's call this dictionary, yeah, we can call it cumulative, like this. And what we would do then is cumulative city equals cases, not daily cases, just cases. And then after we're done, we need to return the entire dictionary. Let me see whether this is actually doing what I think it's supposed to be doing. Yeah, at least the test passed. We could try printing it just to see what we get. Print cumulative. Let's run this one. And as you can see, what we're getting is a dictionary. In this dictionary, we have the city names as keys, and each city name is clean in the sense it doesn't have any extra spaces on the right and the left. And the value for that city is the cumulative number of cases one by one in the list. So let's go through this quickly once again. Here I create the empty dictionary, which is going to be the result of this function working. Then I go through each line of the file. I get rid of the, I'm just thinking I actually probably don't need to do this because I'm anyway gonna strip it. Let me try removing this line and seeing whether it would still work. Yeah, it would give me the same results, so it's we don't need it.
Alex, since you're at this point in what you're going through, an alternative syntax rather than the way you did it for lines 24, 25, and 26 would be, you don't really need data. You could just do city comma cases equals the line dot split. That's an equivalent way of doing this, right? And then you could go from there with cases.
I was not sure because I don't remember this. It could be because probably the first one is going to be sent to city and all the rest will be saved in cases, but I wasn't certain whether that would be the case, so I made it more explicit. But
maybe other people could say, but I'm pretty sure that works. And it's a little more efficient.
I don't think it's, I mean, in terms of how Python does, it's probably going to be the same. In terms of lines of code that you write, you are correct. It's like a smaller number of lines to write. So your idea was, do I understand correctly, like city? But then the question is, did I understand you correctly that you wanted to first save the unformatted data into cases and then formatted it inside a loop?
Yeah, yeah. So rather than the data equals, it would be city cases equal, which would split it up between city and cases, and then you still have to process the cases.
Okay, let's give it a whirl. Let's see. So city cases, we get it like this. Then we still do this here. We do not need this anymore. Then we go for case in cases. And here we just say case. Will it work like, it will not work like this. We need to go over indices. So you would go for I in range len cases. You would have to go cases I equals int cases I dot strip. Is this what you are saying?
Yeah, I think so.
Okay, the only thing here, it's not data, it's, sorry, city equals city strip, like this. Let's check whether this gives us what we are expected, what's expected of us. Nope, too many values to unpack. So,
well, Alex, you don't really need to do this. You know, I'm just pretty sure that, and I'm too sleep deprived to follow what you're doing right now, but I'm pretty sure that the syntax of the city comma cases does work, and you can split it up that way, and then you can further process the city, further process the cases. But I don't want to hold this up by going through that.
Maybe well, I mean, you see that it doesn't work this way. Because here it says that it expects specifically two values. So there is probably another way, and I'm looking like maybe someone in the chat, maybe Ming, will say like this is the way you could do it.
Well, no, it's just this way you get a list with way too many elements, and you're trying to assign it to 2, which is not going to work.
Exactly, because like I was saying, I was unsure whether this would work or not. So my inner feeling was that it wouldn't, but yeah, we checked it right now. So this syntax does not work. There might be another way that I can't come up with off the top of my head right now. And I would actually be interested, Nate, if you are able to find it and maybe later share it with me so that maybe we can discuss.
You can just have the list and pop the first element, that's your city, and the rest is the cases.
And then save the rest to cases. We could actually do that, but then you would still need to basically do what I did. So
yeah, basically.
The only difference with what I had initially, which was, let me get back to it. Did we have this one? Yes. The only difference is that here I'm actually going over data and appending values one by one, where we could have done it differently, first saving everything else into cases. So instead of doing empty list, we could have done data like this, and then go over the elements of that list one by one and fixing them. But my feeling is that this would be faster. I might be wrong, but
I'll go over what I did and send it to you, Alex. It may be that I
dropped it to me in the forum. I'd love to take a look at it.
It may be that I split things differently rather than by comma initially. It might have been by colon. So
the thing is that there is no colon here, because if we had a colon like this, it would have made it easier. That's true. I think maybe in a different assignment, I remember that there were colons, and it would have made it easier, obviously.
Yeah, I don't want to waste any more time. I'll check.
Okay, no problem. Yeah, but if there's something, drop me a note in the forums. I'd love to discuss it.
So, one more question. For cases in data from 1 to the end, if in data from 1 to the end, if we did dot strip, would that work?
You mean write it here?
Yeah.
The problem is that this is a list, and dot strip is a string method. So you cannot apply a string method to a list. You have to actually take every value of that list and apply strip to it, which I'm doing here. That's why I'm iterating over the values.
Okay.
We could have done this differently. Remember, we discussed, I don't remember whether, or did we discuss, because I'm not sure whether, did we discuss list comprehensions? Because this can be done in one line using these three. It could be done using list comprehensions. And let me just maybe write this out here, just an example of what's called syntactic sugar in Python, of how you could do this differently. We could have done the following. Cases is int case dot strip for case in data, and I believe this would give us the same result as these three lines. But let me first check. Or yeah. So the idea for this is called a list comprehension. It's called syntactic sugar because it's something which is not necessary, but it's something in Python which allows you to write code in a single line instead of having to break it up into several lines. So as you can see here, I managed to squeeze these three lines into one line. And this way it works, it says like cases is going to be a list. So these square brackets outside denote that it's going to be a list. And this expression that I have inside says that the contents of this list are going to be this value for each value in this sequence. So it's basically the same thing, but just written in one line. Python iterates over this slice. Each value is stored into case, and for each value of case, this is going to be added to the list that we are creating using this list comprehension. So it takes some time to get used to writing code like this if you have never used list comprehensions before, but once you get used to it, it suddenly becomes easier to write it. You just need one line of code. You can use the map function. Let me think whether the map function would actually be good here. If we go and apply the method to yeah, we probably could have used the map function here as well. Probably. I mean, since we're at it, let's try. If I were to do cases equals data 1, I would still need to do this before doing the map function because the map function requires some sort of sequence. And then I would do cases equals list map str. No, I would not be able to use the map function because I need to do both. I will need to do both a strip and an int, and the map function takes only one function as the parameter. So no, the map function would not work here unless we do it in a very convoluted way, which I do not want to do. So anyway, we can do this like this, or we could do it like this. This is like option 1, this is option 2, select whichever you want. Option 1, like regular for loop, and here we have option 2, which is called a list comprehension. Are there any questions, ideas, thoughts on this before we go?
Just one more, Alex. I'll send you my code, but I think I see what I did, which was doing the key comma values equals, and then I used an extra argument in the split function where I used, the comma as the splitter, comma 1. So I limited to getting the very first value.
Right.
And I could split it those two ways. That's what I did. You understand?
Sure. Okay. Yeah, that's a good idea. I almost never use this thing, so I forget about it. So you can add a numeric value to the split function, which tells you how many times do you want to do the split.
Exactly.
Right. So basically here we're saying sort of do the first split and save it into data and save the rest into cases, but then you would have to do the same with cases. You would have to.
That's right. But that's it.
Okay.
That's it.
Okay, cool. But yeah, for now, let's keep it like this. Yeah, but thanks for bringing this up, because I constantly forget about that option. Any other thoughts, questions, ideas, curses at me? Let me quickly look at what we're supposed to do with the second part of Sandcastle. So the second part is calculating the number of infections per day. We're supposed to do the second function, which does the following. It takes the beautiful dictionary that we created, this one, from the previous function, and now it's supposed to create a different dictionary which has the number of new infections which we get every day. So basically here in day 1 we get 1, and then we're still at 1, we're still at 1, we're still at 1, so there are no more changes. So this means that the first day we got 1, and then we get 0 new, etc. Here where we have 1, 2, 3, 4, 5, 6, 7, the idea is that every day we get 1 new one. Here we get 1, the next one is 1, so it's going to be 0, no new ones, and then we have like an increase. This would increase to 2, this would increase to 3, 5, 8, 13. So this is actually a Fibonacci sequence. So here it is. So the question is, how do we do this one? Daily cases. So we get cumulative as the parameter that we're going to work on, and we're going to create a new dictionary which is called new. We're going to return it at the end of this function. We're going to go over the cities, which are the keys. So for city in cumulative, we are going to create that city in the new one. So we'll say new city equals an empty list, and then we're going to go through this list. So we can actually, what we could do here, we could actually take the first one from the from that specific city. So it's going to be cumulative city 0 and add this to this one, because the first number is always going to be the same. We have here 1, we have here 1. If we had here 10, we would also here 10, because those are the new cases for the first day. And then we would have to go over indices and compare with the previous one and store the difference between the current one and the previous one. So let's go back to the example to be more clear. So for instance, in this situation, we first save let's take this one with Excelsior. We first save 1, and then we're going to go through these values. So we take the second value, we compare it to this one. We see the difference is 0. So we add 0 to the new list. And then what we do, we take 2. Then the question is, what do we compare that one to? We compare it, I think, to the sum of the previous ones. So we'll have
just to the previous one.
But the previous one is 0, so...
No, I mean, you're just looking at that list and not your new list.
Okay, not the new list. Okay, logical. That's quite logical. Yes, we're comparing it to the old list. So here it's the difference between 2 and 1. It's going to be 1. Here it's 1. Here it's 2. Here it's 3. Right, I'm overthinking this. Okay, so we have the first one, and now we're going to go for let's call it value in cumulative city, starting with the first one until the end. Now we're going to go over indices for I in range, starting from the first one until the length of this thing. Right. And I will append to the new city the difference.
I think your range is missing one.
My range is missing.
Like you've gone upper.
Oh, I have. I
city.
need one. Yeah, I need one more parentheses. Thank you.
No, I mean, you're not going to get the last.
Why? I have the length. So if the length is 7, the last one is going to be the 6th index. I'm going to go 1, 2, 3, 4, 5, 6. I don't need the first one.
So you're going from 1 to the length of this list, starting from the first, because you're skipping the first. I mean,
because I already
index,
have the 0th one here, and I'm going to compare I with I minus 1.
Okay.
Yeah.
So what's your last one?
My last one and this one is going to be 6.
Yes, but because range isn't inclusive of the upper.
No. I mean, this one is going to be 7. Oh, okay, I got it. Because, yeah, you're correct. Because since it's a smaller list, okay, yeah, you are correct. I need to add 1 here.
So I mean, yeah, or you just do length of the entire list, because, or just put a 7 in there.
Entire list. True. Yeah. Either case, well, yeah, we could do it like this to make it shorter. Yeah, good catch. So what I'm going to add is I'm going to add the difference between what I have in cumulative city I minus what I have at cumulative city I minus 1, which is the previous index. Since I'm starting at 1, this will not lead to me going out of bounds. The first one is going to be first index minus the 0th index, then it's going to be the second minus the first, up until the last one, 6 minus the 5th one. Yeah, I think this should do it. I don't think there's anything else to do, but let's check, because you can never be sure. It seems to be working. Let's print it out to actually see what we're getting. Print new. Yeah, there we go. This is 1, and that's all zeros, all ones, and we have the 1, 0, 1, 1, 2, 3, 5. So it seems to be working well. So let me quickly go through this once again, now that I'm certain that it's correct. We create the new dictionary of new cases per day. We go through the keys of the dictionary, which is passed to us as the parameter. So we have like Evermore, then Vanguard City, then Excelsior, one by one. We create a new list. So this list, the new one that we're going to have, first by adding the first value. So for instance, here it's 1, here it's 1, and then the last one is also 1. So at this point in time, I have a list that looks like this. Then I go across a range from the first index until the last index. In our case, length is 7, but we disregard the last one, so it's from 1 to 6. So I'm going through 1, 2, 3, 4, 5, 6 through all of these indices, and I append to this list that I already have, I append the difference between what's at the current index I and the previous index, which is I minus 1. So I take here I take, well, this is boring. Like here I take 1 minus 1 and I put in 0, I append 0, then 2, I append 1, then 3 minus 2 is 1, 5 minus 3 is 2, and I do this until the final 6-1. I do 13 minus 8 is 5, and I do not go overboard. So this is the way this one works. Some of the previous two numbers, is this Fibonacci? Yes, that's why I'm saying this. Excelsior is doing Fibonacci. So the next one would have been 21, 34, 55, and so on and on. So any questions, comments on how this one is done? Anything you want to ask or comment here? All right, so this means that we're done with the sandcastle part, and now we have to go through the actual main program, and we will do this in another file. Let me close these two, and the file that we need, I'm gonna skip the introductions. I'm sure you've read through them, and if not, make sure you do, because it's quite difficult to work this out if you have not read. The work is going to be in several files. The one we're gonna start with is rating stats. Rating stats, so it's this one. And what we're doing in this one is the following. We are gonna have some data from this site, which is called ratemyprofessors.com. And what this site has is, for each professor, you have first the rating. So let's take a look at an example file. So this is a small file which has the heading. In the heading, you just have the names of the values that you're going to get. So the first one is rating. So for instance, his, of course, Meran has a 5.0. We have 4.5. We have a terrible rating of 1.0. Then we have gender. So it's going to be either a capital M or a capital W, denoting male or female. And then we have some comment text. It's like a number of words separated by spaces. So anything beyond the second comma is a comment, which is basically a string. So what we need to do in the first one, let me quickly refresh this in my memory. We need to get rid of the first line. So we ignore the first line because it does not have any valuable information for us. All remaining lines should be separated by commas. This first one is the numerical rating, so we're going to store it as a float. The second one is the gender. It's going to be a 1-character string, and the third one is a textual comment, which is a string. It's important it has to be made lowercase and stripped of all punctuation. In order to do this, I believe we are with a function which actually strips the punctuation. Although I might be wrong, maybe I've seen that somewhere else. Maybe I'm mixing up things. I think there was a file which is called a function which was called strip punctuation. Can someone confirm or deny this? Because I did this like a week and a half ago and I don't remember.
Where was it?
I believe there was a pre-written function which was called strip punctuation or something similar. Was it for this?
In this? No.
I don't remember that.
Okay, so then maybe it's from a different, maybe I'm thinking of a different assignment. Okay, so let's take a look at this one. So we get a file name. So this is the file where the information is stored. So the first thing, obviously, that we need to do is to open the file. So we're going to do this with, as usual, with open file name. Let's get into the habit of writing the encoding, UTF-8, because we don't know. Maybe some of the comments are written in Russian or something else, as file. And remember that we need to get rid of the first line. We're not interested in the first line, so the way I'm going to do this is just by using readLine and not saving the result anywhere. So this method reads an entire line, and I could have saved it into some variable, but I'm not going to do that because I don't care about that line. The remaining lines, however, I'm interested in, so I'm going to do for line in file. What I'm going to do with this specific line is I'm going to split it into 3 parts. And remember, the first one is the rating, the second one is the gender, and the third one is the comment. And here I can actually do line.split with a comma, because I know that in the file that I'm supposed to be working with, I think it's this one. No, not this one, another one, smaller. What was it called?
Alex, can I ask you a question about that file, like file read line? You're assuming there's going to be a header, right? Because if the file doesn't have a header, by putting in that line, you're actually going to just skip over the first line.
Yes, that's the idea.
Yeah, what I actually did is I defined header equals to that first line and printed it out, and in fact, it gave the header.
Okay, I mean, you could do this, obviously. You could also install a safeguard. And if you know that the header is always this, you could actually check whether the first line is this, and if it is, then you skip it. Otherwise, you take it in as a comment. But I'm working sort of with the specific assignment.
Instructions, they say that there is a header.
You know that it's a header, so I'm just getting rid of it by reading the line and not saving it anywhere, just skipping over it. So here, we do rating, gender, comment. I save all of them into these three variables. What I'm going to do with the rating first is I'm going to strip it just in case there are extra spaces, and then I'm going to turn it into a float. With the gender, let's do it just in case, just strip if there are any extra spaces on the left and the right. It's a single character. And with comment, I'm going to do the same. I'm going to strip it. And if I remember correctly, it was said that we're supposed to turn it all into lowercase. Let me check. Lowercase and stripped of punctuation. So that's the thing. I believe. Let me check. First I will do lower, then I will do strip. Where did I get this punctuation story? What does it actually mean to be stripped of punctuation? Space separated tokens that have been cleaned.
They're telling you they've already done it.
Okay, I don't have to do it. They have already been cleaned. Okay, yeah. So then I do not need to strip anything. I don't even need to do it in lowercase. So in this case, I can be certain that it's been, so I'll just do a strip just in case. After I get this, what I need to do is calculate the percentage of reviews for both men and women, which is numeric rating that's greater than 3.5. Analyze percentage of reviews. Okay, this is what it's supposed to give us in the end. Is this something that the function does? Yes, it is. So the idea here is that I have to print this out, something like this, after the function is done calculating. So I actually have to calculate the number of high reviews for women. I have to calculate the number of high reviews for men, and then calculate the percentage for both. And a high review is a review which has a rating of that is higher than 3.5. Oh yeah, Abhinav, you're saying there is also a next method I'm not sure why they're actually proposing to use the generic next method here, because I think that the readline method is more clear in what it does, rather than the next method, or is it the next function? I think it's actually a function which works with any kind of iterator, as opposed to readline, which specifically works with a file. So here I prefer to use readline. It's more explicit in what I'm trying to do. So in order to do this, we need a number of variables. So the variables I'm going to do is women reviews and men reviews. They're going to be both 0, obviously. And then I'm going to have women high reviews. I'm going to have men high reviews, and they will also be initially at 0. And here, when I'm going line over line, after I get the rating and the gender, I'm not even going to care about the comment, so I don't have to strip the comment. I would do the following. So if gender equals M, so I know it's a review of a male professor, I will add 1 to male reviews or men reviews. And if the rating is higher than 3.5, I will also add 1 to the M high reviews. And I will do the same for W. So this is a review for a woman, +1 here. And if it has a rating higher than 3.5, I'm also going to add 1 to that variable. And in the end, after all of this is done, I need to write two of these lines. The first one is going to be obviously an F string. It's going to be easier to work through an F string. So we need to calculate the percentage here. This percent of reviews for women in the data state are high, and then we're going to have the same one for men. And so to get the percentage, what we need to do, we need to take the high reviews, divide the total number of reviews for women. We will get a number here. I honestly do not remember the moment I have to round. I think I first have to multiply by 100 to get the percentage, and then round it in order to not have any decimals in the percentage. And probably the same for men. Let me check this quickly. Let's see what happens if we launch this. Okay, we don't have any. How do I check this? Let me maybe run it through the terminal.
Yeah, so that was actually my question. Because if you look at that function, right? When you're opening, you're just opening a file name. And then there wasn't anywhere in the code that actually told you, which file to link it to. And so the way that I got it to run was I had to change the file name to the actual data file I wanted to kind of have it run. And then if you look under define main, there was this thing that asked you to input the file name. And then I wasn't really sure what that input was supposed to do, because even if I were to put in the actual file there, it doesn't automatically feed it into the subroutine. And so I didn't really know like where I was supposed to be calling the actual data file.
But it actually does, if you see the way I did it right now.
Okay, how did you do it?
The question for me is whether when you opened the file here, did you open file name or did you open a specific file which you put here?
Okay, I actually changed the code so that file name is a specific file.
Okay, so that's why it doesn't work.
Well, how did you get your way to work?
Because I didn't change it here, because in main, as you see, you first input the name of the file. So here I wrote the name of the file, like the complete path. So it's in the data folder.
Right. I mean, I tried doing that first and then it didn't work. But I might have mistyped it, or anything, or, and so I had to go back and actually put in the file in the actual file.
Yeah, but the idea is that whatever you type in is saved into this variable, and then you see that the function is called with that variable, so the name is passed into file name here, and I open it here. You could have made a mistake in this part, because it's always like, how do I write this? And you probably
very
have to
possible.
write it differently on the Mac, because on the Mac you have to do the other slash, not the backward slash, but the forward slash. That's the difference in Windows and Macs. So, but as you see, it works, because in our case, we have one review for a woman, which is a high review. We have 2 reviews for a man. One is high, one is low. So we have 100% of reviews for women are high, 50% of reviews for men in the data set are high. But we could actually try this with a different data set. So let me run this again. And for instance, check like small one. We need to do data. Data small1.txt, and it's this, in this case, 100% for women are high, 0 for men. Let's check why. We have 1 high grade for a woman and 1 low grade for a man. Let's try maybe with the last one, which has more data, like this one. We would still get 100 and 0 here, I presume.
The last one is full data if you want.
Which one? Full data. Okay, yeah, we could run full data. That's the large one. So that's the actual, not a test one, but it's a huge one, which has like tons and tons and tons of data taken from a real site. So if we run that one, we will see that 58% of reviews for women and 59% of reviews for men are high, which is close to the number that they have here. They have 57 and 58, but they do say somewhere that it's okay if your data is different by 1%, because there may be some differences in how it's calculated in terms of rounding or the data itself. So that it's nothing to worry about. It says here, yeah, it could deviate by 1 to 2 percentage points. So this is the way that this function works. And given that we have about like 20 minutes remaining, I'm not sure we're going to be able to finish the entirety of all 5 milestones today. So this is probably something which we would have to move to next Friday, because I would want to finish this. But since we have a hard stop today, we have to, end when we have to end. So I'm not going to go through this again unless you have questions. If you do have questions, please do ask them, and then I will make sure that everyone's on the same page.
So Alex, I like your plan of doing this next week, because I think there's a lot to learn from this. I do have a big picture question, which might help other people. I don't know, but I sometimes find that the way they write these problem sets, they're not always well written. And this one, crazy. Okay. Anyway, what I did was, since you know how it all works, is, I did write the conversion of the float numbers to the index numbers. That was straightforward. And then it appeared that they wanted me to do the add data for word function first, helper function, but I saw that it was past the word data dictionary, and I didn't know how that was passed. So I went right through to the read file helper function and did that, and it worked. It got to pass all the tests and everything. And so my question is, the add data for word function,
where is that one? Because I'm not even sure which one we're talking about right now, because I did it like a week and a half ago. I don't remember them all.
Well,
Which-
there's at the very beginning of milestone 1, you have to do a conversion of the float values in the data to indices of low, medium, and high, and create indices for those.
Did I miss that?
We haven't done that. I don't know why it's the other file, and it's
milestone 1.
Okay, hold on. Milestone 1 is writing ratings.
Well, maybe it's at the beginning of milestone 2. Sorry.
Okay, probably we didn't get to it because I remember that. Yeah, here, convert rating to index. Yeah, I remember that one. Sure.
Yeah.
Okay.
So that was pretty straightforward. Okay.
Okay.
But, in the order of how they seem to present things,
Mhm.
there's the helper function, add data for Word. Okay.
Yes.
And it passes as one of its parameters Word data. Okay, which is
Right.
dictionary. But I didn't see how it got passed because I didn't see it being created anywhere. So I went directly to the read file helper function, which was the more complicated one. And I solved that, and it passed all the tests. And it doesn't seem to me the add data for Word helper function is needed at all.
Can you remind me which file that is in so that I
Well,
can
these
actually
are
look
is
at that?
bars data.py.
Yeah.
Okay.
We are
Okay.
by our
So
data.
basically what you're saying, since they're written here in where are they?
Basically, got confused
see
and
the
he
con-
went and did
okay,
the
so
other
here's the
function, which you're supposed to do after, but it still works, is what he's
Okay.
saying.
So I
The
skipped
reason,
that first one, and then I went to the read file one and did it. And I think they meant you to do the first one to help you with the second one, but it's
Sure.
not really necessary. Is that correct? Man, you probably.
Sure. Look, I mean, breaking functions into subfunctions is not strictly necessary. It's your decision as a programmer how much to cram into one function or divide between several functions. And in your case, maybe what you're saying, correct me if I'm wrong, but you're saying that you actually did the add data for Word, and you sort of wrote the logic for converting the rating to an index inside this function.
No, I didn't do the add data for Word at all. I simply skipped to the read file helper function.
So
Yes, you
didn't
probably wrote it inside of the read file.
Yes. And I
You
created.
could write everything in
there.
the same function. You could just
Yeah.
have a main and have everything in there as well.
Okay, yeah. So that's a design decision on your part.
Okay, great.
And
I just wanted to make sure that I didn't miss something because everything seemed to work. And
sure.
I didn't need that other helper function. So thanks.
The reason why they are asking you to do it into separate helper functions, because that's the way it's done when you start writing large programs, because like novice programmers always have the desire to write everything in one function, or even don't do functions, right? Just, like a whole page of code. And it works with smaller programs. So yeah, in terms of getting the end result, it doesn't matter how you do it, but it's good practice to start writing small helper functions, because that makes putting code together and reusing this code a lot easier. So the answer to your question, as you already understand, is yes, it's not necessary to write these two functions, but it's good practice just to get used to the idea of one function doing one small thing instead of one function doing a bunch of different things. Does that make it? Does it?
Yeah,
does
no,
that...
I totally get that, Alex, and I actually think I really like the idea of doing things in small steps, particularly at my level.
Right.
But because I got totally confused about how the Word data was passed into the add data for Word function, I thought I had to do the read file one first. So I did it first. Then after I did it and went back and read stuff, I said, oh, okay, now I get it. You wanted me to go through this slowly, but I did it anyway. And then that's what happened.
Sure. Yeah, it's a bit difficult in the sense that you sort of do a sub function and then you don't know whether you're supposed to use it somewhere because no one tells you that you're actually supposed to use that sub function. And you sort of go, well, maybe I don't need to use it. Maybe I can do this all in one function, which I do agree with your assessment that sometimes the assignments are written poorly. I agree with this. This is something we constantly discuss with Vicky, but there is a certain advantage to that because, believe it or not, in real life, assignments that you're gonna get as a programmer or working with Python, whatever, if you're gonna get assignments from someone else, they are going to be ugly as well, and you will probably have to work with assignments that are not perfect. Vicky, how much time do we have left? I'm just wondering whether we should
you have,
actually.
I'm sorry, you have about 17 minutes.
17 minutes. We
You
could
probably do milestone 2.
We could
Plenty of
probably
time. You
do
can speed run it.
Yeah, they are. It's not that difficult. So basically, let's go through these functions. So the first function we have that we were just discussing right now, convert rating to index. The idea is that you have 3 indices. Like every rating falls into one bucket. I just don't remember what are the breakpoints. I have to see them in the less than 3.5 and more than 3.5. And everything else is in between.
So quick question, Alex. Okay. Yeah, because it was driving me crazy because I wrote everything, including the subfunctions in the rating stat.py. And then I didn't realize, I was like, where are these like doc tests? Okay. And so apparently we're supposed to write each of the milestones in separate files.
I don't think it applies for each milestone. So there are some milestones which are written together in the same file. But yes, it actually says in each milestone which file you're supposed to write that in.
I don't think it's, well, I mean, unless like I couldn't read.
It says also the function.
Totally like.
And the file.
Oh, okay.
Well, let me quickly.
It's fine. Please move on. So
like for instance here, like milestone 2, it says both functions are in bias bars data.py. So
both
here,
function, where does it say that? Can I like,
it's like if you look at the screen right now,
all my,
if you look at
it's really
screen,
confusing.
Highlighting
You everything until you get to milestone 5, you're in that first script.
Yeah, I think so as well.
Yeah,
I don't remember. Okay, so back to, since we don't have, back to convert rating to index. As you see, it's a very simple function. I hope I got it right, but let's do the doc tests quickly. It seems, yeah, it's running the doc tests correctly. So basically I'm saying if the rating which is passed to me as a parameter is less than 2.5, return 0, because that's what it says here. Like low reviews are 0s, medium reviews are 1s, and high reviews are supposed to be 2s. Now that's is that what it says?
Yeah.
Okay. So yeah, I did the low one. I declare the middle ones. So yeah, I don't think there is any point in looking at this one. It's simple. So the next one is add data for Word, and this
one is hard.
I will have to, I need to remind myself of what this one is, because update the word data dictionary. Okay, so we get a dictionary as a parameter, and then we get a word with the gender and the rating, and we need to, I suppose we need to check whether this dictionary already has this word for this gender and for this rating. If it does not, we need to add the word in there. If it does, we need 1. Does that sound correct? Because yes. I'm doing this from memory.
Yeah.
Yes.
Okay. Let me
It was very easy, but I think the doc test had something wrong with it. I had to add some tests and rewrite them. In case it fails for you. I don't know.
I do not recall
VS
having
Code.
issues with it, but yeah, let's check. So basically what I'm doing is I have the dictionary, the word, the gender, and the rating. So what I need to do first is I need to check if inside word data, the first key that I'm using is the first key is the rating. So I need to check if
If the word is not in the dictionary, then you just create the inner dictionary.
Oh, sorry, good. Okay, sorry, I got mixed up. Good is actually the word we're looking at. Okay, so if we're saying if word in, or let's say not in our dictionary, then we need to create a new key. So we need to do word data with the keyword, and inside we need to create a sub dictionary which will have two more keys, like the large W, or do we actually have we have them as keys here, like I don't know what the reason is, but we could use it like key women, and it's going to be a list of 3 zeros, 0, 0, 0, and then we have the same key men, 0, 0, 0. So the idea is if the word is still not in the data, we need to create a sub-dictionary which has the number of instances that women had received good reviews, like this is actually bad reviews, average reviews, and high reviews, and the number of reviews men received also, bad reviews, average reviews, and high reviews. And the reason why this is bad, this is average, and this is high, because these are the indices that we're returning, because the bad review is at index 0, a good review is at index 2, and an average review is at index 1. Once more time, is the good review more than 3.5, or am I mixing something
Yes,
up?
yes.
Yeah, is it? Yeah. Okay, 3.5, okay. So another case, if the word is already in there, we need to increase it by 1, I suppose. Yeah, so then we go word data for that specific word, for that specific gender, for that specific rating, we do +1. And what we have here, so that we understand what this line of code means, is it says, take the dictionary word data and look up the key, which is the word. So for instance, in our case, if it's the word good, we'll look up the key under word good. And under the key good, we have another dictionary that has gender as the key. And in our case, we have this gender passed to us here as a parameter. So we're looking in that dictionary at that specific gender, be it W or be it M. So that way we are getting access to the list, which is stored under that key, either W or M. And here we get access to the entire dictionary. And this entire dictionary, we get the gender, so we get access to the list. And the rating is actually the index of that list. So we're adding to this one if it's a poor comment, here if it's an average comment, and here if it's a high comment, a good comment.
So
that's the one we're adding one to.
Do you actually have to convert the rating first to the index? Because if you're just taking the rating, you know, it's kind of
right,
like
correct. Yes. Sorry, I forgot that here the rating is actually, here is where we need to use this.
Which means you have to call that convert rating index function first.
Yes,
and then
I can actually call it right here.
Oh, okay.
I could have done it like this, and then edit rating here, but I mean, why spawn multiple lines where you would actually call the function here, convert your rating into either 0, 1, or 2, and yes, edit here. But good catch, I forgot that here the rating was actually a float and not the index. So
you have to add it in your if as well. in the first statement, if the word is not in the dictionary, then you're just going to get the word added with 00000, right?
Yes.
But the word has appeared and you should be adding it in one of those. One of those zeros should be a 1.
Okay, because yes.
Because otherwise you're gonna just get good
right.
W00.
You're absolutely correct. So we actually don't need an else. I'm getting a bit tired as well. Thank you for helping out. So the idea is that if there is no word, we are going to create an empty dictionary, but then in any case, we're going to add to that dictionary. So yeah, that one slipped my mind. Let me quickly see what you're writing in the chat. The ratings for connective files before. Okay. So let's check whether this works. It seems to be working. It's not throwing any errors from the doc tests. I think it's running all the doc tests once you press it here. So yeah. So with this one, are there any question on how this works? Do you need any explanations, clarifications?
I don't have any questions on how it works, Alex. But I'm really dense here, but in the helper function itself, word data is a parameter. Where does that get passed from? To start off, is it just an empty dictionary? How did it get created in the first place?
I mean, in this specific case, I don't even care, because for the moment, I'm just writing a helper function. So I know that I'm going to get some sort of dictionary, and I mean, since
that's where I got confused, because I figured, well, where the heck does it come from? And
you can look at the doc test. It shows you the very first line, create an empty dictionary.
Yeah, here specifically, it runs this function several times. So the first one in the doc test, it creates an empty one.
I get it, but it doesn't mean that was created someplace else as an empty dictionary.
No.
And I found that really confusing.
My guess would be, let me quickly check whether it's in here somewhere. So we have it, and then probably get passed somewhere into search words, and search words probably uses that function. I don't have an answer for you direct right now because I don't remember.
It's the next function that you read the file and you start adding the words into a dictionary.
Okay. So it's in the idea is that you build your helper functions one by one, and then you start using these helper functions in the next functions that you're writing. So sooner or later, we'll get to using this function and passing something into it. And obviously, we're going to read that stuff from a file.
But so anyway, see how I got confused, and other people might get confused too. So, you know, it just was really confusing. Anyway,
I do tend to agree with the higher level of confusion with these assignments. They're not as clearly written as you'd probably want, but I'd say it's actually good exercise to try and make sense of what they want to get from you, because unfortunately, this is the way life is. So yeah.
Alex, can you explain what the +=1 was?
Which one? Which line?
Yeah, the word data, word gender, convert ratings to index ratings, and then +=1.
This one?
Yeah, line 77, yeah.
Are you confused about the entire line or specifically this?
I mean, specifically the one. Like, I understand that we're appending, I mean, we're adding all of this to the file, to the word data list or dictionary. But then what is the one?
It's one word. You found one. You found you found this word. For instance, we're taking the word good, and this means that you found the word good in a review left for a certain gender for a certain rating. And you're sort of aiding, for instance, if you found that the word good was used in a review for a man with an average review, this +1 would be added here. So this would become 1. And this means that reviews of male professors of average quality have one more word good.
Okay.
Does that make sense?
Yeah.
Okay. I think we should stop here because we have only 3 more minutes, and I do not want Vicky to, have any issues. So let us return to this next Friday and spend some time on finishing this. It will probably take a small chunk of us discussing classes and object-oriented programming, but I agree that it's worth it finishing this and getting all the questions sorted. So that's that for today. Thank you everyone for being here, for your participation. Vicky, you are free to kick all of us out.
Thank you. And then